Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is very similar but a little bit different, of course, from the previous ones. So we have the same body on the same surface, the surface has no friction, and we apply this force F1 to the right and we apply force 2 to the left. And they say F1 equal 2 newtons and F2 equals 2.5 newtons. And mass of the body, let's say 2 kilograms. And they want to find us acceleration. Standard operational procedure. Picture. Body on the surface. Forces. External force F1 to the right, 2 newtons, and F2, external force to the left, F2, and it's 2.5 newtons. Whom else this body is interacting with? Of course, pause. Of course, it's interacting with Earth, and it is mg, gravity, nothing else. Of course, it's also interacting with the surface because it wants to fall down, but mg pushes it down, but surface prevents it, so surface pushes it back up and pushes it with m, normal reaction, and there is no friction. When there is friction, we will be doing this, there would be another component of the force that body is interacting with the support. But here it's mg and that's it. Next step, pause. Of course, the sum of all forces equal AMA in vector form. Never be lazy to draw this, to write this equation. It will make yourself more confident and your physics teacher pleased. And the next step is, because we have to expand this f, we have to write f1 vector plus f2 vector, and I have to put here the vector signs everywhere, plus n vector plus mg vector equal ma. And I write them in a little bit different order than in the previous time, but the order doesn't matter. The sum of 1 plus 2 and the sum of 2 plus 1 is the same. So the sum of vectors doesn't matter in which order we draw these vectors and this. Substitute these vectors in this sum sign. Okay, next step, of course, this is y and this is x. And of course those are perpendicular to each other, and of course in this case it's only natural to align them with the directions of all the forces. Right, so x is this, so F1 is that way, positive. F2 along the x, totally along the x, minus. And 0, mg 0, because n is vertical and mg is vertical and x is horizontal, so no projection on this axis. Equal, and of course we know that body is moving with acceleration a in this direction, so ma. That's it. A, y-axis. F1 is 0, no projection on y. F2 is 0 because F2 has 0 projection on this vertical axis. Plus n goes vertical and it's the same direction, so it's positive. Minus mg equals 0 because no acceleration on this way, so no acceleration here. F1 minus F2 equal ma, and n equal mg, and the same, it's a mathematics now, and question mark is a, and question mark is n, exactly like before. Two equations, two unknowns. Nobody is even asking us about n, but if they ask, it's very simple. It's mgm multiplied by g2 multiplied by 19.6 Newton, if they asking. But this is basically that everything is in balance along this line. But A, yes, we can divide this A equal F1 minus F2 divided over M. And this is our solution. Let's plug the numbers. It will be 2 minus 2.5 divided over 2 equals minus 0.5 over 2 equals 0.45 over 2. 0.5 over 2. It would be minus 0.25 meter per second. That makes sense. Minus means that we assume that A is directed this way, direction X. This is why we put it here. It was unknown, so we assumed it's going, but it's in reality it's going this way because F2 is 2.5 and this is 2. 2.5 pushes stronger that way than 2, and that's why the resulting acceleration is that way, and it's reflected with this sign minus and minus here. What else can we say? That acceleration is the difference of those forces. Of course, the net sum of those forces, if one pushes you left and another right, you have to subtract one from another, and it would be like the net force that pushes you in one direction only. And in this case, F2 is bigger than F1, so F1 minus F2 is smaller than 0, it's negative, and it's going that way. So, really it would be the same like to say there is no F1 and there is only one force this way, and this force will be 0.5, the difference between those. So that's why this acceleration is 1/4 of what it was before, because the net force was 0.5 instead of 1 Newton in previous program, and mass is double. Other than that, pretty straightforward. You still like it, and if you're not subscribed, subscribe and put bell and ask a question. Thank you.